we have an angle here is what we're going to describe or define. And as you can see up here, it's named or it's formed by two rays that intersect at the same endpoint. And there's different ways to name it. So let's kind of look at what that is. You'll need to write this down. All right, so if we draw an angle, so I have some endpoint here, all right, and then I draw a ray going one direction, and then a different ray going in some other direction from this same endpoint. Right? That's going to give me an angle. All right? And usually one way that the angle is named is with the vertex. So if I put that as my vertex A, then I could call this angle A. Okay? Something else that you might see is if you have two other points, we'll do B and C here. The other way that I can name it is I can call this angle BAC, okay, by going, from one point to the vertex to the other point. Okay. I could also call it angle CAB. Right? It's important for these two ways to name the angle that the vertex always goes in the middle. Okay. So it's BAC or CAB. I can't jump from one point to the other and then back to the vertex. It has to go consecutively around the points. And the other way that you'll see this named is you'll see some number up here like a 1 or it might be a 2 or 3, whatever. And so you would call it angle and then whatever number is inside in the interior of the angle. So this would also be called angle 1. Alright, now so up here it says that the region that contains all points between the different sides of the angle, we have an interior side and we have an exterior side. And so all the points that are in between the two rays or inside the two rays, that's what we call the interior. Everything else would be the exterior. Alright, so now we're going to name some angles from this drawing here, this diagram. And there's 3 angles that are in this thing. So you have to be able to see them and name them according to what is given. So the first angle that I see is this angle out here. Now the problem with this, or not necessarily a problem, I can't just use this vertex here. I cannot just call it angle M because there's different angles here, as you're about to see. I have this angle right here that's on the outside, and so I have to use these points here. So the first one I would name it as angle JML. And that's talking about this outer angle. I have another angle right here going from J to M to K. So that would be angle JMK. Then I could also go here. I would say that this would be, if I go on this bottom ray here, starting there, I would say I have an angle LMK. Notice that my M is in the middle, that's the vertex, for each of these angles. Alright, now, and so I can't call it angle M because I don't know which of these 3 angles you're actually talking about. Alright, this next thing we have is what's called a protractor postulate. And basically what this is someone came up with a way to measure these different angles. And so what they did is they decided to use the numbers 0 to 180 to measure these angles. The important part that you need to know here is that just right here, this little M stands for measure. So I'm talking about the amount of degrees in an angle. So when you see that little M, that means measure of angle AOB. Alright, next, this hopefully should be some review stuff for you. These are the different types of angles that we have. Of course, there's acute angle, right angle, obtuse angle, and probably maybe if there's any that you haven't heard of, it would probably be the straight angle, which would just be, if I have 2 opposite rays, that would give me a straight line. So we could call a line and a straight angle. For our purposes, they're going to be the same when we're talking about the measurement being equal to 180 degrees. Alright, so real quick, we're going to kind of talk about how to use a protractor. Now, this little dot right here, that is where you would line up your vertex. It would go down here, like so. Alright, now notice that there's this black line on the edge. You would have to line up either ray with that black line. So the vertex and this ray would have to line up. Okay? And then if you're reading from this direction, you're going to use these inside numbers. And if you're reading from this direction, you would read the outside numbers. So this angle right here would be about 64 degrees. Okay, and we'll talk about that here in just a second. I'll give you another example to look at. Okay, and here are these other examples that we're going to look at. Don't expect you to draw this compass out, but I do want you to watch and kind of see what we're doing. We're talking about this angle GHK. All right, so this is already lined up for you. Since I'm counting, or since I'm going this direction, I'm going to use the top numbers. Okay, so if I'm going from GHK, I'm going to read until I hit that other ray over here, which happens to be 125 degrees. So the measure of angle GHK would equal 125 degrees. Now if I'm looking at JHL, notice the ray HJ is this bottom angle, and then HL, ray HL is going this direction. So for this one, I'm going to read this way, which means I want to use the inside or the bottom numbers. All right, so JHL, I'm going to come from 0, I'm going to go up, and it looks like that one stops right at the 90 mark. So the measure of angle JHL is 90 degrees. And now I need to look at LHK. For this one's a little different because it's not at 0. So what I have to do is I have to look at the 90, and I'm going to use this side over here. So this one's going to be 55. That's at the 55 degree mark. So what I need to do for LHK is I need to actually subtract 90 minus 55, which ends up being 35. So the measure of angle LHK is equal to 35 degrees. Next we're going to talk about congruent angles. Now on a diagram, you'll notice there'll be these little kind of like tick marks that we have for segments. They're arches. So you'll have arches to tell you which angles are congruent to which one. So up here, angle G has one tick mark. And it might be a little hard to see on the screen, but angle B here also has one tick mark. So on this one for A, I would say angle G is congruent to angle B. And then also F right here has two arches. Angle D has two arches. So that would mean that angle F would be congruent to angle D. All right. So if we look at angle for B, part B, the measure of angle ADC, so that's this angle. So if this is 140 degrees, what is going to be the angle measurement of angle EFG? Well, since they both have the same number of tick marks, that means that the angle EFG is also going to be 140 degrees. All right, the next thing we have is what's called an angle addition postulate. Now, it's very similar to the segment addition postulate, where I can take a segment, and if there's a point in that segment, I can split that segment into two different parts. So on an angle addition postulate, I can take an interior point P, right, and if I draw a ray from the vertex to P, that divides the angle into two different parts. Those parts may or may not be equal, but it doesn't change the size of the angles. So I can take this angle RSP, and I can take the angle PST. If I add those two, it's still equal to the sum or the measure of this outside angle here. Here's this example. Given that the measure of angle LKN is 145 degrees, we want to find the measure of angle LKM and the measure of angle MKM. And this little M right here stands for measure. We would read this as the measure of angle LKM. Just a little bit of notation information for you. So let's get started. The angle addition postulate says that I can take these two smaller angles here and add them to get angle LKM. So the angle addition postulate using symbols would say that I can take the measure of angle LKM M plus the measure of angle MKN, that's going to equal the measure of angle LKN. Okay, so using what I know, I can substitute. I would say, okay, I have 2x plus 10 plus 4x minus 3 is going to equal 145 degrees. All right, now I can combine like terms, so this 2x and 4x would give me 6x. And I have a plus 10 minus 3 is going to give me plus 7. So then I subtract 7 from both sides. That goes to 0. It tells me 6x is equal to 138. And if I divide by 6, it tells me that x is going to be 23. Okay, but again, we're not done because it doesn't say find x. It says find the measure of angle LKM and find the measure of angle MKN. All right, so now let's do the measure of angle LKM. That's equal to 2x plus 10, right? So now we have to substitute. We're going to do 2 times 23 plus 10. All right, so that's going to give me 46 plus 10. So that's 56 degrees. Okay. And then if I plug it in down here for measure of angle MKN, that's going to be, that's 4x minus 3. So I have to substitute. That tells me 4 times 23 minus 3. All right, that's going to come out to be 89 degrees. All right, and then the last little piece on this part of the notes is going to be bisecting angles. And there's this word right here, angle bisector. Basically, that's a ray that divides the angle into two angles that are congruent. So this is the statement that you need to know. This ray YW bisects angle XYZ. So that means angle XYW is congruent to angle ZYW. Okay? This is going to be probably the common way that you'll see this given to you. All right? So you're supposed to interpret that for this drawing and see, notice the tick marks here that shows you these two smaller angles here have the same angle measure. All right, so let's look at this example here. Notice the statement, it looks very similar to what we have up here. QS bisects angle PQR. So the very first thing I'm going to do is I'm going to draw my angle PQR. All right, and I know QS bisects it, so that means that point S right here is in the interior, and it makes it so that these two angles are congruent. All right, and I know that PQS is 24 degrees. I want to find PQR. Well, if this part is 24 degrees, because it's a bisector, that means this angle here is also 24 degrees. So if I want the measure of angle PQR, I would just double my measurement, so that would be 24 times 2, and that would be 48 degrees. Okay, that would be my answer.